Hi, and welcome to this video. My name is David LeMay. I'm a mentor with Team 247, Berkeley High School, First Robotics Team, Da Bears. Today, we're going to be talking about reference variables. This video series is meant to be not an introduction to Java, but I have found that there are certain topics that are not very well covered in Java classes that are aimed at beginners, such as you might take in a high school class, but which are important when you do real-world programming, such as the kind that we do in a FIRST robotics program. So I have a couple of videos on topics that kind of get overlooked and that go into a little more detail on things that will help you understand what's going on. The last video was about primitive variables. This video is going to be about reference variables, which are any variables that are included in a class. Let's demonstrate this call by reference and the use of reference variables. So all class variables are reference variables. So I've got some of our sample code from our previous video. I've modified it a little bit. In particular, in the sample class, I've added two variables called match1 and match2, and the type of the variable is match. And if you remember, match is a class. So let's go to the Explorer, and it has fields in it that will allow you to store the team numbers of the match and the scores and things like that. So this is for your scouting application. We're going to create this match that will contain everything about a match that is important. Okay, so this will declare it. What happens, how is this actually stored? What happens when you declare it? Well, let's go back to our memory map where I showed in the previous video, I showed how to store ints and chars and things like that. Now I'm going to store, what's match going to be stored as? Well, if you look here, it's got 32 bits. I've got match 2, it has 32 bits. I'm saying when I say declaring a match, it says, okay, give me 32 bits here, and because I'm going to put something in it that represents a match. And when I say declare another match for match 2, give me another 32 bits. Okay, but what's actually in it? If there's only 32 bits, and a match contains a whole bunch of ints, and an int is 32 bits, how can it store everything about a match in a single set of 32 bits? Well, the answer is it can't. What it can store in those 32 bits is an address. Remember, these are all the addresses. They're the numbered cells in your memory where data is stored. And when I want to store a match, what I do is I put an address in here. So let's say I'm going to put in 1 million. I'm just going to put it in this top line here instead of spelling it out in each of the individual bytes in these lines. I'm just going to say I'm going to address 1 million. And then if I go over here, what I've got over at 1 million is the contents of it. So match1.r1, that's an int, so it's going to take 4 bytes, and that's going to be stored in these 4 bytes. So I'm saying 1 million, and the first thing in it is match1.r1, and it's going to put the 4 bytes of match1.r1, which is an int, into these bytes. And then match1.r2 is going to be in the next 4 bytes, because it's the next one in line. You start out with R1 and then R2, however you declare them. You never really have to know these things, exactly where they're stored. you just know that wherever it is, you've got an R1 and an R2. And this contains the original cell that you declared is going to eventually contain this address value. We call that a pointer or a reference, and that's why we call them reference variables. We're going to say here at 1002, we've got the variable name match1. The contents of that are 1 million. So if I go off to 1 million, now I can find the contents of it, and here is going to be the actual values that we're looking for. And if I declare another one, and let's say I put in here 1,100,000, then later on in the table I've got 1,100,000, and it's part of match 2, so the first 4 bytes at 1,100,000 is going to be match 2.r1, and that's going to take up 4 bytes, and then it'll be match 2.r2. So here's the takeaway. The value of a reference variable that is associated with the actual variable name is an address. The address points off to some other portion of memory, and it contains the actual values of all the member variables that you've declared for a copy of that class. All right. Why do we need these things? Well, we just need to keep our values together, for one thing. We've got all our match 1 values pretty close together. So that's kind of handy. But it also allows us to change variables inside functions. And let me show you what I mean by that. I'm going to create a function which might be used to during scoring. Probably wouldn't be, but this is just an example. So I've got this, what happened here? Oh, this add a goal function. Public void add a goal. A goal is worth 3 points. So I take my original score and I add 3 to it. Great. That's wonderful. Let's see what happens. And I've got that in my main function. So I've created a sample variable because everything has to be part of a class. So I have to create a class to store it. So sample.example score, and then I'm going to call add a goal passing sample.example score. What is sample.example score? It's an int. So I'm going to pass an int to my add a goal function, and it's going to add 3 to it. So let's run. Okay. And I've printed out the line before and after, and what happened? Original score is 50. Modified score is 50. But I added 3 to it. All right. When I'm calling a function in Java, I can't change the thing that I call. It won't work. So what can I do instead? Because I want to change the score. Well, how about if instead of doing it the way I just did it, let's go to this to add a goal. And let's see, let's go to implementation. So here I am, add a goal. I'm going to make a new function. And I'm also going to call it add a goal. This is going to be confusing, but instead I'm going to pass a match. And I'm going to say match score dot b1 plus equals 3. All right, so there I've done that. Match score dot b1 plus equals 3. And so that's excellent. Now, instead of changing an int, I'm passing a match, which is a class variable, meaning it's a reference, and I'm saying, go to the thing that you've referenced, find b1. Remember, in this table, it's going to be one of these variables. I've used r1 and r2, but the next thing would be r3, then b1, b2, 3. Find that and change it. I can't change the thing that I passed to the function, but I can change the thing that I'm referring to with that pointer. So I'm passing a pointer, a reference, an address. They all mean the same thing. I'm passing a pointer that says find that and change it. Okay, so now I'm overloading the function. So instead of passing example score, I'm going to instantiate a match. I'll tell you a little bit more about that in a moment, what this instantiation is all about. And then I'm going to use that to call the function. Okay. And so here we go. And that b1. Okay, so now what you notice is instead of calling match underscore 1, instead of calling it with an int, I'm going to call it with a class variable. And now let's see what happens. Start debugging. And my original score was 0. My modified score is 3. See, I cannot modify the thing that I pass. Sample.match1 is going to contain the same number than it did before because it's at the same address. This can't be modified. But the thing it points to, sample.match.b1, that can be modified. And that's how we use reference variables. Now there's an important thing that you have to do with a reference variable. I referred to it as instantiation. Let's do something. I'm going to take out this line. This is a mistake that you're going to make when you're programming. You're going to make this mistake a lot. People always make this mistake. New programmers don't realize how to catch the mistake that I'm about to show you. But you're going to make it. And if you pay attention to this part, you won't be confused when it happens, and you'll be able to fix it really fast. So I'm going to do exactly the same thing I did before. I've got match 1. I'm going to call it sample.match1, b1, b, we're going to call add a goal. Everything's going to work exactly the way it did before, right? Well, of course not. I wouldn't be saying that if I was asking. Let's see what happens. Okay, uh-oh. Look what happened. Exception in thread main, java.lang.NullPointerException. What does that mean? Let's go back to our variables storage. When you declare a variable, what you do is you make space for that variable, and you put a 0 into it, or whatever the initial value is. It's usually 0. So for example, if I declare an int a, I'm going to do this. As soon as the declaration is encountered by the compiler, it's going to set up these 4 bytes as a. And whatever value is in here, that's what a is going to be. Well, it's going to do exactly the same thing with reference variables. We have match 1. It's going to put 0 in them. But I don't want 0 in them. I want this pointer. I want this thing to point over here. If I run it here, it's going to say 0, and it's like, well, I can't point at reference 0. These are all 0. That's what null pointer exception means. This null pointer exception that you get, it's because over here you called it match 1. As soon as you did that, it saved 4 bytes to put the address of match 1 in there, but it hasn't made anything there yet. That value is still 0. And if you try to call something with that value 0, you get a null pointer exception. It's saying sample, well, we know what sample is because we created one. Dot match 1, well, that's 0. Dot meaning something it points to, but it doesn't point at anything because it's still 0. It is null. That's why you get a null pointer exception. In order to actually create the value so that it has something to point at, you have to call the new method. That's what the new method does. So when I call this, over here in my memory map, that is when I'm going to fill in this value. So when I declare it, meaning before I run the function at all, just by the compiler, it's going to set aside 4 bytes for a pointer, but it's going to put zeros in it. When I call new, now it's going to go over here. It's going to find some bytes that it's not using right at the minute. And once it finds those, it's going to put the first one of those in here. So I've got this area at 1,000,000 over here. So all of a sudden now these 4 bytes are going to be 1,000,000. And now the first 4 bytes pointed at by 1,000,000 are R1, then R2. Eventually it finds B1 and it can do what it needs to do. That's a very brief introduction to what a pointer is and how it gets there. Here's the part I want you to take away. Here's the part I want you to remember, because here's the part that you're going to get wrong in your first robotics programs, and I want to not waste lab time looking for that. I want you to know right away, oh, of course, that's what always happens. You will see when your code runs that it will stop. When a program stops, it's because something has happened called throwing an exception. And somewhere it'll print out what exception is thrown. An exception is a thing that it doesn't know what to do with, so it's just going to stop. Period. I'm going to do a video on exceptions later, but for now we're just going to talk about this one exception, and that is the null pointer exception, because that's the one that's going to happen the most often, and it's going to confuse you the most. Well, it shouldn't confuse you once you know it. Now that you've seen this video, you will know what to look for, because the null pointer exception in almost every case means you forgot to call new. Once you call new, you won't get the null pointer exception because, well, your pointer is no longer null. New is the thing that creates the pointer and also finds some variable storage to put your values in for the class variable. If you want to learn more about this, how it's done, I recommend looking up on Google Java heap memory. All of the stuff, all these addresses over here, come out of something called the heap. And it's a little bit like it sounds. It's like all these memory thrown together in a big heap, and it just looks for stuff that's available, and it keeps track of which ones are available, which ones have been used, and which ones haven't been used. And so that's sort of if you want to go into it. What you need to know for FIRST robotics purposes is when you see the null pointer exception, and you will, find the variable that you forgot to call new for. That'll fix it. Now I want to take a look at a couple of things that I went over very quickly during that explanation and pay just a little bit more attention to them. The first is something called overloading. I referred to it. Here we have a function. In Java, there are usually called methods. I've been programming a long time, and I tend to still call them functions. That's what we used to call them. I don't know what you'll call them 10 years from now, but right now they frequently call methods. Methods, functions, even subroutines, they're all the same thing. So you have a method called addAGoal, and you have another method called addAGoal. And they look exactly the same name. So that might be problematic, eh? Well, it isn't really, because in Java, you can have two functions with the same name as long as they have different argument lists. This is addAGoal that takes an int. This is addAGoal that takes a match as its argument. And if you pass a match, it will know to find this addAGoal instead of that addAGoal. Be very careful when doing this. Remember, other people have to read your code, and they might not understand it, so be very careful. Just make sure it's very clear why you're doing it, and keep them all close together on the same page. Otherwise, nobody will be able to understand your code. Another thing I want to talk about is the word that I used called instantiation. There's a big 10-cent word. What does it mean? Remember, we have a class. So here's our class match. And this is sort of an abstract idea. We know that a class is a match, and whenever you have a match, you'll have R1, R2, R3, B1, B2, B3. You'll have each of these fields, which are what variables called when they're inside a class. You'll have each of those fields and each of the methods. When you actually create one of these, we call it an instance of the class match. You create an object. That object is an instance of match, and the act of creating an instance is called instantiation. So if you ever hear me talking in the lab about instantiation, I mean creating an instance of a class, and what that means is calling new. Because that's what new does. New is the constructor. It constructs a class, or an instance of a class. So when I say new match, I am instantiating the variable sample.match1. I am turning this into an instance of the class. Okay, let's summarize the important points of this video about reference variables. So the value of a reference variable is its address. When you create one, you create a pointer to an area in memory. If that pointer is 0, which it will be when you create it in the declaration, 0 is also called null. Using it will cause a null pointer exception. Call new to create a new instance of the class. This is called instantiation. Creating an instance, instantiation. If you forget to call new, you will get a null pointer exception when you try to use the variable. One of the things that reference variables allows is it will allow you to change variables from within a method. You can't change what's passed in, but you can change the thing it refers to or points at. Oh, and did I mention the null pointer exception. Yeah, that's kind of the point of this video, is to make sure that your pointers always point at something. Look for the null pointer exception. It means you forgot to call new. Thank you for watching this video. I hope you learned something useful. You may find it useful when you actually get into programming at the lab. Our next video is going to go into a more practical demonstration. I'm going to talk about motors and their use in FIRST robotics programs, and how we address them, how we create them, and how we use them in programs. So a little bit more practical information, a little bit less theory. Hope to see you there.